Okay, today we are going to talk about lesson 15 of module 2, and that is the informal proof of the Pythagorean theorem. Um, Many of you know from last year what the Pythagorean theorem is, and that has to do with right triangles. So for our notes this year, just to remind us, we're going to write that down. Pythagorean theorem is for right triangles only. It doesn't work for anything else. And what it says, the formula is that a squared plus b squared equals c squared, where a, b, and c are the sides of the triangle. Now the important piece of information to this is that c is always going to be the hypotenuse. And for those people that don't remember hypotenuse, what that means is that it is the longest side of the triangle. That's what hypotenuse is the longest side. So A and B can be the other two legs. They can go in any order, but C must be the hypotenuse. So our first triangle right here that is shown, just on the side, we're going to do a little application of this theorem here. So if you have AC is 6 and CB is 8 and then AB is C, this is what you would do. You would assign your A, B, and C. So I'm going to make 6A and 8B, and then C is already labeled here. So I'll just highlight it again. And we're going to use our Pythagorean theorem, a squared plus b squared equals c squared. So we're going to say then 6 squared plus 8 squared equals c squared. And then don't forget that 6 squared is not 12. It's not 6 times 2. 6 squared is either 6 times 6, or in your calculators you can do 6 caret 2, both of which will give you an answer of 36. Okay, so 6 squared is 36, plus 8 squared is not 16, that's 64, equals c squared. And then the next step is going to be to add these two together. 36 plus 64 is 100. And that's still not our final answer. Even though you have it down to a single number, it's saying 100 is c squared. We still have to undo this squared sign. So just like the opposite of add is subtract, the opposite of multiply is divide, the opposite of squared is to take the square root. So to get our final answer, we're going to take the square root of 100, and that is equal to 10. So C equals 10 in this case. And that makes sense. 6, 8, and 10. It would not make sense had it been 6, 8, and 100. And that's how we use our Pythagorean theorem. And for today, we're going to use the same process for every single problem that we do. Tomorrow we'll talk about how to find the legs A and B, but today we're just going to be finding the value of the hypotenuse C. It will be very helpful if you have a calculator either on your computer or a hand calculator to do this, because although this one worked out a nice even 10, they don't all do that. So you're going to want to have a calculator handy here. Okay, so let's move on to another example. So example 2 here, determine the length of the hypotenuse of the right triangle. Let me zoom in a little bit. Okay, so in this case, you have some different numbers here. So, and you can assign them any way you want. This time, just to show that it works, we're going to make 7a, and we're going to make 3b, and then here's our side C. And we're going to use our Pythagorean theorem. I'm going to write it down again. A squared plus b squared equals c squared. So we're going to say 7 squared plus 3 squared equals c squared. 7 squared is 49 plus 3 squared is going to be 9 equals c squared. Then we want to add our 49 plus our 9 to get 58 equals c squared. And remember, Ask yourself if that makes sense. If you think you're done, a side of 3, 7, and 58, that's not possible. So we do need one more step. The opposite of squaring is to take the square root of 58. And I'm going to show you on the calculator because this is going to require some rounding now. Okay, so if we have our calculator turned on, oh, I have to clear mine out. So we're going to have, on this calculator, I have to press second square root here. That's above the x squared, which is on lots of them. 58, and you want to end the parenthesis. If you're in a scientific calculator, it'll start with 1, you have to end with it, equals, and it says 7.615773106. For the sake of this lesson, we are going to round everything to the nearest tenth, so that's the first spot after the decimal, so we're going to say C is about equal to, and this is a new sign for many of us, 7.6. If we're rounding, we don't use the regular equal sign. We're going to use this wavy equal sign, which means it's about 7.6. That means we rounded it. Okay. Every single problem is like this today. You set it up the same way, just like we did both of our examples. So for the sake of the lesson, this is going to be the end. The assignment that goes with this starts on page 86. So 86 looks like this. It has a lesson summary on there. And then the problem set starts here, number 1 and 2. We're going to go all the way to number 12 for the assignment today. So starting on page 86, 1 through 12 would be the assignment. If you have any additional questions, please come and see me either before school or at lunch.